Next, I need to introduce, if I could get my pad to work, Maynard Koch from TU-Dresden, who's going to talk to us about resilience. Welcome.
Yes, thank you very much for the introduction. My name is Maynard. I'm a PhD student at the TU-Dresden. And today I'm going to talk a little bit about our current project, which is joint work together with the Internet Society, about measuring the resiliency of recursive DNS resolvers. So, resiliency is challenged by multiple incidents. These incidents can be attacks, misconfigurations, and also censorship, which all lead to outages. And the idea is, of course, that a resilient domain name system withstands these outages. So there are several mitigation techniques that have been developed in the past to help make the DNS more secure, more reliable, and also more resilient. But of course, the DNS is still not perfectly resilient. So the Internet Standards Community, the IETF, has published several operational best practices to improve DNS resiliency. Still, operators must make their own decisions. They need to trade off security, cost, and also complexity. And since these decisions can impact the security of billions of internet users, ICANN has proposed an initiative to codify the best practices into a set of global norms to improve the security. And these norms are called the Knowledge Sharing and Instantiating Norms for DNS and Naming Security, for short, KINDNS. So the goal of this project is to conduct an independent study on the measurable practices of the KINDNS framework, as well as other important DNS resiliency practices. So what are we going to do here? What we try to do is we try to improve the resiliency of recursive resolvers by taking a measurement perspective. So we need to first understand the DNS resolver ecosystem, and then, of course, assess how resilient the domain name system is. And how do we do that? We start with collecting multiple public data sources to assess the resiliency. And for example, we use the IPNIC DNSSEC validation measurements. We also use the Manycast API to check whether a resolver is in an Anycast deployment or not. And we also use, for example, the Spoofer API, and we use the OpenDNS API to check whether the recursive resolver is deployed in an environment that does source address validation, or it doesn't. However, to fully understand the resolver ecosystem, we cannot solely rely on external data sources. That's why we are also going to add active measurements, internet-wide measurements, to better assess the resiliency of recursive resolvers. As of now, we started running query name minimization measurements, and we're setting up DNSSEC measurements to check whether a recursive resolver actually does validate DNSSEC or not. And of course, more measurement will follow. So let's head into first results. So this is only a very brief overview to give you a better feeling of the current coverage of this project. So we use the OpenDNS API to collect all the open resolvers and also to infer the non-public resolvers Our current coverage is that we have in our database about 35,000 open resolvers distributed over more than 5,000 ASs, and also about 70,000 non-public resolvers distributed in more than 8,000 ASs. So what can we do with that? The first idea was, okay, we can just check and correlate with the spoofer API and the other measurement API whether these open resolvers are deployed in open recursive resolvers are deployed in networks that seem to allow spoofing or not. So what you can see here is basically just the top 50 economies ranked by their total number of open recursive resolvers. We also indicate the number of ASs that allow for spoofing in that country. And on the y-axis, you can see the total number per country of open recursive resolvers. And on the right x-axis, you can see y-axis, you can see the share of resolvers that are deployed in networks that seem to allow or appear to allow spoofing. So the TLDR of this graph is basically that of the 35,000 open resolvers we have in our database, about 36% seem to be deployed in networks that appear to allow spoofing. So yeah, quite a surprisingly high number. Stay tuned for more measurement results here. This is only a very brief glimpse into the first results. And with that, I would already like to open the discussion because, of course, we want to get feedback on in this early stage of this project. And if you want to contribute data, please talk to us. We're happy to integrate these data into our measurement and into our analysis. And I would finally like to ask you the question to open up the discussion of how you would define and assess resiliency of the domain name system. So thank you very much for your attention. Do not hesitate to ask any questions. Thanks.
Do we have any questions?
I think it's first.
I think you made it first.
Am I on?
Yes.
Audible? Okay. So
Can you say who you are and your affiliation,
absolutely.
please?
I apologize, Kathy. I'm Shuman Huck from Salesforce. So one very important aspect of resiliency that we have to deal with whenever there's an outage or a partial outage is proper retry and failover behavior. Generally speaking, a lot of resolvers do this correctly. For example, if you have an invalid signature or an expired signature, do they retry other servers? But there is a population of resolvers out there that do not, and that causes huge problems. Is this an aspect that you intend to measure?
That is actually one part we're going to try to investigate and check how well do these resolvers actually implement these best practices, and that actually indeed includes also retrying and running regular measurements to check whether they fail or not.
Okay, great, thank you.
Cool. John?
With Quad 9. Shuman stole half my question, so I'll ask the other half. So when you say resolvers, are you looking at ingress or egress IP addresses classified as a resolver? Because with anycast, there's a huge proportion that's
yes,
racial.
Both. So for non-anycast resolvers, we are looking at the ingress IP addresses, and for anycast deployments, we want to look at the ingress IP addresses, and we also want to get to know or understand the back-end deployment of the anycast addresses. So we also look at the egress IP addresses that we see in our setup, basically requesting at the authoritative name server.
Okay, and sort of stacked onto that question is actually stacking, where an open recursive sits in front of another open recursive. Do you account for that, or is that part of your examination? Because that, of course, the more stacking you have, the less resilience you have.
Sure. I'm not sure how good our current data set coverage is there, but of course, I think currently we would mark or flag a recursive resolver in front of another recursive resolver as a forwarder, basically.
Forwarding cache in front of a
Yeah.
recursive, yeah.
We are also analyzing them. We do have them in our database currently. And yes, we also want to know how they depend on each other. So if there's, like, for example, one certain DNS recursive resolver that is used by 500,000 forwarders, for example, and how dependent are these interconnections? Yes.
Thank you.
Okay.
Ralph Akamai. So you said open recursive resolvers, and they are susceptible to spoofing. So, I mean, where do you get the list from? Because if the list is kind of like coming from a scan of the internet, sure, there's tons of servers out there that are misconfigured that, of course, will accept any spoof packet whatsoever. Yep. So I think if you want to really test resolvers, these are kind of like noise that really don't matter too much for the actual operation.
You're speaking of the spoofing part.
Well, in general, open recursive resolver, I mean, people do this these days. It's simple. Yeah. You do a scan of the IPv4 internet, and you get open resolvers. But probably 90% of them are just misconfigured devices somewhere in the internet. Sure, they are not really relevant. When you talk about resilience, you talk about the resilience of real users, and these are not real users. So that's...
yes, I mean, we do need to understand the DNS ecosystem, and we do include this open resolver term just also includes the public, so the intended resolvers, like...
Sure, and I think that's important, but I think you need to distinguish because otherwise you are screwing the result. That's
sure. We need to make sure that, as you said, to distinguish and have an overview of actual real deployment and the use cases, the clients they use, who use these resolvers. Yeah. Yes.
And there's one small nit. You said you're talking about resiliency, and one of the things you had in there was queue minimization. That's privacy. That's not resiliency.
Yeah, sure. I mean, it's part of the best practices, more or less.
That's true.
Of course, I
just
agree.
Yeah.
Okay, I think we have time for two, maybe one more question. Raffaella?
Raffaele Sommesi, University of Twente. I have a question that's basically related to what Ralph asked. Do you have any idea of how you can implement some metrics about popularity of resolvers that you're looking at least to avoid this queuing of results?
I mean, it's maybe a bit hard to measure. We try to... There may be some data sources out there that also, for example, the popularity list of domain names. Maybe you can correlate that with some cache snooping, for example, and check and try to estimate the usage of this resolver. But what we try to do is to check how dependent is, for example, to come back to one of the previous questions, how dependent is a forwarder on a certain resolver, and how often are, for example, public or popular public resolvers used. So that way we could get an estimate of how popular these resolvers are.
Maybe a suggestion is that you can also look at DDoS data to try to estimate how much query transit through a recursive resolver.
Yeah. Thank you.
Peter?
Hello, Peter Thomason from DESEC. So Ralph stole half my question. Here's the other half. The 69,000 non-public resolvers, how did you get that list?
We have the set of open resolvers or public resolvers, and we have a set of forwarders that forward to some other resolvers, and then we just correlate if they forward to these open resolvers, which anyone can just query, and if not, we flag them as non-public resolvers because they're more ISP resolvers and they're only available in a limited environment.
So you always count them as distinct then, even if they might be forwarding to the same resolver?
Again, if they forwarding to the same resolver, then it's still the non-public resolver.
Yes, I was more confused about how high the number was.
Because you think it's quite high, the number is quite high? Yeah.
It was my impression.
Of course.
I don't have any data, so that's why I asked how you came up with it. But thank you.
Thanks.
So thank you very much to Maynard, and the discussion can carry on the Mattermost channel.